Yo guys, what is going on, mi amigos? Yes, I'm just waking up. It is 4 o'clock. Sometimes those days happen, and I am unapologetic. But the reason why I woke up today at 4 o'clock, uh, read the video that I uploaded yesterday, talking about distractions and whatnot, and how horrible I am with them. That is why I went to sleep at, I don't know, 7 in the morning or something crazy like that. Is because I've been working on this neural network uh, algorithm testing fun thing is super fun. I think that neural networks are super fun. Um, so I don't know. Today's video, I just want to kind of show you my progress and just talk about it a little bit because I think I really need to move on. Like it's getting into the not healthy stages. Um, cool. Here we go. Here it is. Boom. So what you're looking at here is this is one neural network. This is a separate neural network, and this is a third neural network. How this is working is I have 3 monitors, and each one of them are running its own evolution of neural networks, right? And so let me break this down. Let me break down everything that you see. So I think it's probably the biggest one on the screen. So what you see here, this is a character, and this line right here is showing the way it faces. It's very rough, and then he has inputs and the way that it works, essentially, it has the same controls as like a real person would have. Like if I were to play this game, I'd have the same controls that this character, that all these characters are using. Forward, backwards, turn. I haven't added jump yet, but forwards, backwards, and turn. Those are pretty much all they have control of at the moment. Now, with every move that they make, they're rewarded. Up here in the corner is their fitness level. If you know anything about neural networks, this is, the repeat for you. But they're rewarded for every move that they make, which is what their fitness level is. And the higher their fitness level is, the more chance they have to reproduce and pass on their genes. And so, as you can see here with some of them on this one, the highest fitness is 33, so they all have like the genes from the 33, just as mutated plus or minus, which is how you get to that's how you get improvements. So you can see the tactic here. Okay, so the goal, real quick, is they want to find the end. They want to find the end marker. That's their goal. So the closer they get to the end marker, the better the fitness is. All right. So what we can extrapolate from these 3 evolutions is they're all roughly around the same fitness: 34, 33, 31. I don't even know if you guys can see these variables or not, but I'll tell you. This first one right here is 31. The second one right here is 34. Last one is 33. And as you can see, the tactics that they're doing is they are kind of going, or at least these two, they're going southern, boom, boom, and they're trying to get around that one, trying to get around this right here. Um, now, uh, there's a couple more things I need to tell you. The objective is actually behind this wall a little bit, and these transparent little cubes, if they collide with them, then their time slows down dramatically. So you can see that some of them will hit the cube, and then they'll start to turn. Like they'll head for the cube first, and then they'll start to turn. Um, like this guy, for example. See how he just exploited that to leverage himself? Like that is a really good thing to pass on. He did it again right here. Um, and the thing is, with neural networks, uh, the thing why I like it so much is because it's, when I was a kid, or I don't know what age I discovered neural networks itself, but when I discovered it, I thought that it was a computer literally learning how to get better at something. That's what I thought it was in a literal sense, because they always use a learning algorithm and things like that. But that's not particularly true. The algorithm doesn't exactly learn. It's more of like the process of elimination through evolution. That's what it's more like, which isn't bad, but it's not as exciting as I thought it was going to be before I learned any of this stuff. But anyways, um, back to my point. So I'll show you again up here. My hotkeys aren't working. Hold on. My hotkeys are not working now. I'll show you. So up here, you can see the generation. This is the 274th generation, genome 7 out of 15. So how it works is that this pool right here has 15 different characters with slightly varied stats. And so once the genome gets to 15 out of 15, it starts over and starts a new generation. And in that new generation, the best fighters from the previous generation, they will pretty much mate. So they'll take their best stats and they'll make like a new population. Um, that's based on the top four. It's a variable that I can easily change. They don't have any say in that. So over time, like if I were able to run this to like 10,000 generations, you they'd be able to develop very, very smart um, methods of going through this course, right? I think that for my prediction would be at 10,000 generations is that they would be able to identify these transparent versus these blocks right here, and they would know that if they go to these transparents, then they will get an edge. Like it's good to be in there, so they'll go to there, they'll go there, and then they'll be able to exploit that. And then the black boxes, they'll know to avoid them because they'll get stuck on those. Um, yeah, man, it's oops, wrong screen. It's it's very complicated if you don't understand neural networks. I know I'm not doing a good job, and what you're watching is probably incredibly boring. But I don't know. I have been really addicted to this over the last couple of days. It's really fun to watch a computer like get better over time using the process of elimination or survival of the fittest. I'll say I won't say that. Yeah, I don't know, man. I'm starting to like ramble at this point, but these are the things that keep me up at night when I should be doing other things. I don't know how to fix it other than just like keep on doing it until it gets boring. Like right now, I feel just like I feel satisfied with the progress that I made to take a break and work on the important stuff, and then come back to this at a later date. I feel satisfied. Uh, but yeah, man, I really want to add a speed up function where I can get to 10,000 generations really quick. I'm not sure the math I should take that. Okay, guys, that's pretty much it. I hope that this video was at least something enjoyable to watch for you. If not, I'll see you guys tomorrow. Who knows what we're gonna see tomorrow? Peace out, my friends.